Hello student, in the video lecture series of heat transfer, in this video we are going to learn the overall heat transfer coefficient. So what is meant by overall heat transfer coefficient? It is the ability of material of a composite material to transfer the heat flux per unit temperature difference. So per unit temperature difference, when we maintain the 1 degree temperature difference, at that time how much heat flux will be get passed through that material, composite material. But if there is a single material, we write it down thermal conductivity and all that parameter or overall heat convective heat transfer coefficient. But if it is a composite material, at that time for a unit temperature difference, how much heat flux will be get transferred through that material, that ability is shown by the overall heat transfer coefficient. So Q is nothing but the heat transfer, but when heat transfer take place with unit area, so from the unit area how much heat is get transferred is called as an heat flux. And when there is an 1 degree temperature difference, at that time how much heat flux will be get transferred is known as an overall heat transfer coefficient. According to the Newton's cooling law, Q is equal to UA delta T. So Q is equal to delta T upon 1 upon UA. So we write it down in terms of electrical analogy. So 1 upon UA will becomes a thermal equivalent. Now for this system, whole system, thermal equivalent, we can write it down. UA is equal to 1 upon RTH equivalent. So this whole system or this material and atmosphere offer the resistance to flow, but the heat is get transferred because this is the ability of material due to its thermal conductivity, its ability of atmosphere which having some convective heat transfer coefficient. Due to that, heat is get transferred. So how much whole this system will be transfer the heat, not only this material, not only this material, not only this atmosphere, whole this system, how much heat will be get transferred, that will tell you by the factor that is known as an overall heat transfer coefficient. Now next concept is nothing but the contact resistance. Now simple example I am taking. If this is one slab and this is second slab, if this is maintained at 100 degrees Celsius over here will be at a 70 degrees Celsius, and some of the temperature will be get dropped on same surface and it will become 60, and then I will get over here a 50 degrees Celsius temperature. Ideally, if I draw same cube, so same example, here I will get the 100 degrees Celsius, here I will get the 70 degrees Celsius, and here I will get this, let's say 55 degrees Celsius temperature. So there will be no temperature drop at this surface if the case will be an ideal. But practically there is an temperature loss will be take place. So why this temperature loss will be take place? Because these two surfaces are not 100% smooth, and when they are not smooth, their contact will be like this. So if you see the contact in a microscope, there will be an void space, and inside this void space there will be an air. So this air will be offered some resistance, and due to that resistance your 10 degree, 5 degree, 3 degree, whatever may be the temperature will be get lose, and this lose in the temperature due to the void spaces, due to the resistance of this air which is get trapped inside the void spaces. That resistance is known as an contact resistance. So how to reduce these contact resistances? If you use the logic, you will get the answer. First, if I am pressing this both the surface onto each other, then this void space will be get reduced. So first method to reduce the contact resistances is nothing but to apply the pressure. Second method, what we do, we can increase the smoothness of this one so as to there will be no void spaces. So increasing the surface finish, ultimately there will be a decrease in your void spaces, and contact resistance will be get reduced. And third method is nothing but there are some thermal greases. If we apply these thermal greases on both the surface, there will be a no chance for trap of air, and due to that also your contact resistance will be get reduced. So we apply the thermal greases. Likewise, you can decrease your contact resistance. Okay, thank you.